The manufacturing process encompasses approximately 1,000 steps over 3 months, yielding multiple CPU chips from each silicon wafer. This intricate procedure highlights the sophisticated technology underlying microchip production. An integrated circuit or chip comprises various elements such as cores and memory controllers, integrating billions of transistors that function collaboratively. A thorough understanding of these components is essential for comprehending CPU functionality. Transistors are produced at an astonishingly small scale, with dimensions measured in nanometers. This diminutive size is vital for the efficiency and power of contemporary processors. The process initiates with layers of insulating silicon dioxide and photoresist, followed by the application of patterns using UV light. This sequence illustrates the complexity involved in microchip fabrication. Following the creation of each layer, the wafer undergoes rigorous cleaning and inspection to prevent dust particles from contaminating the meticulous manufacturing process. Within the semiconductor fabrication plant, overhead transport systems and robotic arms facilitate the efficient movement and processing of wafers through various fabrication stages. Central to the process is the creation of a mask layer on the wafer using tools like photolithography. This allows for precise patterning of nanoscopic features, a crucial step in CPU design. Photomasks play a key role in replicating designs for billions of transistors onto multiple CPUs simultaneously, showcasing the efficiency of contemporary semiconductor manufacturing techniques. This dependence on optics is essential. Each CPU chip necessitates multiple layers, specifically 80 different photomasks, highlighting the complexity and expense of semiconductor fabrication. Notably, each mask can cost around $300,000, signifying a substantial investment. Deposition tools introduce materials like metals and insulators to the wafer through specialized methods, ensuring that layers are appropriately formed. Each tool serves a distinct purpose in this intricate process. Etching and chemical mechanical planarization, or CMP, are crucial techniques for material removal from the wafer. These methods prepare the surface for the subsequent addition of new layers. Ion implanters alter silicon at an atomic level, an essential step for creating the necessary regions for transistors. This process is subsequently followed by annealing to repair the silicon lattice. The wafer undergoes various processes, including etching and CMP, to create a flat layer of insulating silicon dioxide and conductive copper, ensuring precise patterning essential for the microchip. The semiconductor industry tends to be notably secretive regarding its manufacturing processes, necessitating extensive research and modeling for this video. This emphasizes the complexity and proprietary nature of microchip production. Silicon wafers are produced by refining quartzite into pure silicon and slicing it into delicate wafers, which are fundamental for chip fabrication. The cost and value of these wafers significantly increase once they are populated with CPUs. Intel categorizes its processors into tiers like i9, i7, i5, and i3 based on the number of functional cores. This structured classification aids consumers in selecting suitable CPUs for their specific needs. Post-fabrication, chips are meticulously cut, positioned on interposers, and thoroughly tested to ensure their functionality. This careful procedure guarantees that only reliable components enter the market. Brilliant.org provides interactive learning resources focused on technology, aiding individuals in understanding complex subjects such as chip manufacturing and artificial intelligence. Their customizable courses cater to diverse skill levels, promoting independent learning.